On this one, two airplanes leave Watertown. We're going to use the fact that distance equals rate times time. We know the total distance equals the speed times the time. And it says one travels 30 miles per hour faster. So I'm going to say we got two planes. I'll call plane 1. I'm going to call that X. Makes sense to call it R, but I'm going to call it X. Plane 2 is 30 miles per faster, so X plus 30. After 3 hours, the planes are 3,150. Now, the important thing here is they're going in opposite directions, aren't they? Since they're going in opposite directions, we have plane 1 going this way, we have plane 2 going this way, and then the total distance is 3150. So what I'm going to do is I'm going to write an expression for plane 1. So plane 1, its distance is going to equal to its speed, which is x, times the time, which is 3. I think I'll write that as 3x. And that's for plane 1. Plane 2, the distance is going to be the time, which is 3, times x plus 30. Or I could say 3x plus 90. Now I know together these two planes go 3,150. So I think that's what I'm going to say here. I'm going to say, 3x plus 3x plus 90 equals 3150. Well, 3x plus 3x is 6x, plus 90 equals 3150. Well, let's subtract 90 from both sides. So 6x is going to be 2160, right? Then I'll divide both sides by 6. I can't do that in my head, so we're going to take 2160, we're going to divide it by 6. And we get 360 miles per hour. So the first plane is going at 360 miles per hour. The second plane is going at 390 miles per hour. I must have changed numbers on here because I just copied the answer from a problem I had. I didn't do the work ahead of time. I should have, because we can see it's going to be 360. Let's make sure I didn't type that in by mistake. 2160 divided by 6, that's right. Okay, so it should be 360 and 390 miles per hour. Or not miles per hour, miles. Oh, the speed of the plane, because x is speed, so it should be 360 and 390. There we go. Now, on the last question, let's take a look at number 26. It looks like a complicated question, but if we take a look at it, we just have to identify what we're supposed to find and then do that. It says, a ball is thrown up in the air at an initial velocity of 53 feet per second. Okay, so that's my initial velocity. In the first 1.5 seconds, that's my time. It travels 42 feet. That's my distance. The formula x equals u plus t over n times t represents the vertical distance the object travels. So x is going to be 42 then, isn't it? Okay? In t seconds, so t is going to be 1.5. U represents the initial velocity, so u is 53. Okay, find the velocity. I want to find the velocity. Well, the final velocity must be n then, right? So we're going to substitute everything we know in. So x is going to be 42 equals parentheses u, which is 53, plus 1.5. My parentheses looks kind of sick there. All over n, which that's what I need to find, times t, which is 1.5 again. Now we're just going to solve for n. So 42 equals 54.5 all over n times 1.5. So then 42, if I take 54.5 times 1.5, we get 81.75. So equals 81.75 divided by n. Now n's in the denominator, and I prefer when n's in the denominator to take the reciprocal of both sides. So we're going to say 1 over 42 equals n over 81.75. Then to solve for n, we multiply both sides by 81.75. So in other words, I'm really going to take 81.75 and I'm going to divide that by 42. And we get about 1.95, don't we? So n is 1.95. And so in a complete sentence, don't forget the units. So I'd say the velocity of the ball is about 1.9 feet per second.